So taking a look at example 1, this is a nice question that kind of breaks down the three different types of equations you're going to see. So in any trigonometric equation, there's three variables. There's an angle, and then there's two side lengths that make up the ratio. And so I'm going to set up the equations for each of these three triangles to solve for the unknown, and then we'll come back and actually solve. So in this case, I have the angle 23 degrees. I have the opposite side, which is 17.9 centimeters, and here's my unknown, which is the adjacent side. So I'm going to set up my equation by saying that the tan of 23 degrees should be equal to the opposite side, 17.9, divided by x. Okay, and so in this case, I'm solving for a side length, and that side length ends up being in the denominator of my ratio. In the next triangle, I have 55-degree angle. The opposite side length is my unknown, and I'm given the adjacent side. So very similar to the previous question, except for my unknown side is now going to be in the numerator. Okay, and finally, in the third example, my angle is unknown, but I'm given the opposite and the adjacent lengths. So tan of theta is equal to 29.7 over 15.3. And the side lengths aren't really relevant because they're going to cancel out, so that ratio doesn't have units. Okay, let's take a look at solving each of them. So in the first triangle, I want to solve for x, so I'm going to multiply both sides by x to get x up into my numerator. So we can see that the x's cancel out. And so now I have the equation x times tan 23 is equal to 17.9. Then I'm going to divide both sides by tan 23. And I'm going to get x is equal to 17.9 over tan 23. Okay, because tan 23 canceled out on both sides there. Lastly, I'm going to punch that into my calculator, and I'm going to solve, and we end up getting, I actually don't have the answer, so I'll let you guys ring that through. Let's take a look at the next one. So the next one, kind of silly because it's divided by 1, but if it were something other than 1, then we would simply multiply both sides by the denominator so that these two things would cancel out. Okay, so in this case, x is just equal to tan 55. Okay, and lastly, I want the angle, so if I have the ratio, then I'm going to do inverse tan of the ratio to get the angle. Okay, so I'm going to draw a quick little diagram down here just to help you understand this relationship between an angle and a ratio. So if I have an angle, which is commonly represented by theta, okay, I can get to a ratio. And in this case, because I'm talking about the tangent function, then that ratio is specifically the opposite length divided by the adjacent side length. Okay, and to get from this angle to this ratio, I am simply going to do tan of theta. Okay, to get from the ratio back to the angle, this is where I'm going to use the inverse tan function because I'm doing inverse tan of the opposite side length divided by the adjacent side length.